Hello, my name is Max. I'm CTO and data scientist at Supervisely. And in today's computer vision tutorial, I'm excited to introduce the new framework that we recently released into Supervisely platform. It's called HRDA. This framework takes synthetically generated images and unlabeled real images and trains state-of-the-art semantic segmentation model on this data. And it means that we can train very cool and accurate model without any manual annotation, and it will be robust and perform very good on unseen real images. Right now I will show you how to do that, and all technical details you will be able to find in our blog post. I will attach the link in the description of that video. Let's start. Here's my Supervisely account, and to train neural networks in Supervisely, you need to connect your computer with GPU. It can be from your home, office, or from the cloud. To do that, you need to go to Start page, Team Cluster, and as you can see, I have several machines connected. Once you connect your computer, you need to go to the list of projects, your data, and neural network section, HRDA, and run the app train HRDA. I will, in advanced settings, select the computer with actual GPU I want to use for training and press Run button. So right now the app is started, and let's open it. So here's our interface. It's quite straightforward. On the first step, we see the input project, then we select the model. We will use pre-trained model instead of custom weights, but you can of course use your weights as well. Then we have only one training class, it's Cracks. The source labeled dataset, for source dataset, we will use synthetically generated cracks. For target dataset, we will use real cracks. These images are unlabeled, and the model inside will use a lot of beautiful techniques like domain adaptation, multi-scale resolution, scale attention, sliding window, and all the things to train the model on synthetic data, and then use real unlabeled images to pseudo-label them, and then to learn on these labels during the training. It's really cool. And that's what about selection of train validation splits. Let's now define the training augmentations. You can use default ones. For this experiment, I did my custom augmentations with Image Augmentation Studio app, and you can find it in our ecosystem. And I already did custom augmentations. I will copy them from the team files. Here they are. I have a config for custom augmentations. I just copy path. I just need to paste the path to my custom augmentations and load this template. Here it is. We can preview this template on random image. As you can see, they have performed a lot of different transformation, colors transformation, a bit of elastic transformations, and here is the image, augmented image, and crops, flips, rotations, and stuff like that. After that, in the training hyperparameter page, we can define the experiment name. For example, in my case, it will be HRDA cracks. Then I want to define the number of iterations. I will train 20,000 iterations. I will increase slightly a batch size because I have a lot of GPU resources on my machine, and slightly increase the checkpoint interval. It means that every 4,000 iterations, the checkpoint will be saved. And also, I prefer to slightly increase the warm-up. It means that the learning rate first 500 iterations will be slightly increased to the defined value. In most cases, it works very good. And the last step, I just need to press train button. As you can see, the training is started. For my experiment, it took about 5 hours to train very good and robust model. Here on the screen you will see the final charts. As you can see, the training loss decreased over time, validation accuracy is good and increased, and the model is stable, and all the training artifacts are saved into the team files. Let me show you right now how the model after training perform on real unseen data. I just need to go to team files page. Here is my previous experiment, and here we have a lot of different models. I will pick the best checkpoint and copy paste to it. Now I can go to the neural networks page and find in the category of semantic segmentation special app for deploy this model trained by HRDA framework. I just need to run this app, and I will select the same computer with GPU and press Run button. App is ready. I paste here the path to my checkpoints, and I will deploy it on CUDA device and press Serve button. Right now the model weights will be downloaded to this machine and deployed, and it means that I can send requests to it and other applications from our ecosystem can communicate with this model. The model is deployed right now, and let's apply this model to the test images. To do that, I will use the model right inside the labeling tool, but you can apply the model to an entire project. I showed it in a previous tutorial. You'll find the link in the blog post. And let's open the images. Here is a test image. I will use special app. It's called Neural Network Image Labeling. I will run this app right inside the labeling tool. And in this app, I will be able to connect to this model and apply this model to my images. Let's apply the model. As you can see, the predictions are quite good. I don't need the background, and let's increase a bit the opacity of the figures. Here is another image, and I can apply this model as well. I can go over the images, find examples, and apply the model to the image. For example, this one, as you can see, the prediction is almost perfect. This next one, and so on. And in such manner, I can use this model and pre-label my dataset effortlessly. So that's it for today. I encourage you to try to train this model on your data, or use our demo samples that we shared in previous blog posts and try to train such model and reproduce the experiment. Thank you for watching. I hope you enjoyed this video, and please press the like button and subscribe to our channel to watch more computer vision tutorials. See you soon. Have a nice day. Goodbye.